In this example, I will look at a hypothesis test for population proportion. The problem says Nexium is a drug that is used to reduce the acid produced by the body and heal damage to the esophagus. The manufacturer claims more than 94% of patients taking Nexium are healed after 8 weeks. In clinical trials, 213 of 224 patients were healed after 8 weeks. Test the manufacturer's claim at the 0.01 level of significance. After reading the problem, I typically pull out the key information. I noticed that there was a sample taken, and the sample size was 224. I also see that the number of successes in that sample was 213. The alpha level, or level of significance, is 0.01. And we have a claim that's incorporating the number 94%. This is our population proportion. Now that I've identified those pieces of information, I go to step 1, meet the hypothesis test requirements for the parameter being tested. First thing, we need to see if this was done with a simple random sample, and the problem does not indicate that it was, so we're going to assume it was a simple random sample. Next, I need to calculate NP times 1 minus P and see if that's greater than or equal to 10. Now the P in this problem has to do with the population proportion, so it's our 0.94. You can see I calculated the sample size multiplied with the population proportion multiplied with 1 minus population proportion and got 12.6. This is more than 10. I can continue. Next, I have to assume that the sampled values were independent of each other. Step 2, state the claim. The claim is that more than 94% of patients taking Nexium are healed after 8 weeks. So I rewrote that under state the claim. Step 3, state the null and alternative hypothesis. Remember, the null hypothesis always has equality. Since my claim has the word more than, I chose a greater than sign for the alternative hypothesis. Then I need to figure out what symbols and numbers I put in. Well, I put a P because I'm dealing with the proportion, and I put in 0.94 since that's the population's proportion. If I was doing a hypothesis test for the mean, I would use a null hypothesis with the symbol of mu and equality. Then I would put the population's mean. The alternative hypothesis would also have the mu symbol, but it would either have a less than, greater than, or not equal to, depending on the claim. And the null hypothesis for a standard deviation would be sigma equals population standard deviation. Alternative hypothesis, sigma, with either a less than, greater than, or not equal to, and then the population's standard deviation value. Determine the level of significance, and this is notated with alpha. Well, I had already found that alpha was 0.01. Frequently, it'll be a 0.05. Step 5, determine the p-value with StatCrunch. In StatCrunch, we would go to Statistics, Proportion Statistics, One Sample with Summary. We write in the number of successes, which was 213. I write in the number of observations, which was our sample size, 224. The value for our population proportion was 0.94, and our alternative test had a greater than sign, so I hit compute. My p-value is 0.2462. Let's move down to step 6. In step 6, if our p-value is less than alpha, then we reject the null hypothesis. Well, our p-value was 0.2462, and our alpha value was 0.01. We can see that our p-value is definitely greater than our alpha value, so we're going to fail to reject the null hypothesis. For a formal statement on our decision, we need to look at our flowchart. Looking at the flowchart, does the original claim contain the condition of equality? Well, we would select no because it was greater than. Did we reject the null hypothesis? No, we failed to reject the null hypothesis. So our formal statement will be along the line of there is not sufficient sample evidence to support the claim that more than 94% of people taking Nexium will heal within 8 weeks. You'll see in step 7 that I've typed up that formal statement. Now, only students or adults that have taken a statistics class will know how to interpret that formal statement. It's usually beneficial to restate the decision using non-technical terms. So one way to write this up is, the manufacturer's claim that more than 94% of patients taking Nexium are healed after 8 weeks is not valid. Remember, steps 5 and 6 can be replaced with a more traditional format of the hypothesis test. We can break step 5 down into 2 parts. The first part being, how many tails are in the test? And what are the critical values? Well, this is a one-tailed test as our alternative hypothesis has a greater than sign. If you have a not equal to, then you have a two-tailed test. But we have a greater than sign, so we have a one-tailed test, and it's going to be one tail to the right since this is a greater than symbol. I have used a picture of a normal curve, and I place the significance level in the right tail. So the area that's green represents 0.01% of the overall area under the normal bell curve. Next, I use the normal distribution to determine the critical values for the area in the tail being 0.01. In this case, I use the normal distribution because I am doing a hypothesis test on a proportion. If I was doing a hypothesis test on a mean, I would have to use the t-distribution. If I was doing it for the standard deviation, I would need to use the chi-square distribution. Let's go to StatCrunch. Go to Stat, Calculator, Normal, because we have a normal distribution. We have a right-tailed test, and the area to the right is 0.01. I hit Compute, and I see that my critical value is 2.33. That means the vertical line here for our critical value is 2.33. That's our z-score, or our critical value. The critical region is considered to be the area, or that whole region to the right of the critical value. Next, I need to determine the test statistic. There are formulas for it, but I recommend you use StatCrunch. The test statistic was found in that same hypothesis test. You'll see that it's the second to the right number, 0.69 in this case. So my test statistic is 0.69. 0.69 in regards to the mean is a little to the right. This value obviously is not in the critical region, the green region that we originally shaded. Because the 0.69 is not in the critical region, when we come to step 6, then we fail to reject the null hypothesis. We only reject the null hypothesis if our test statistic fell within the critical region.